Hello, Matt Davis here with more homework quiz help. This one comes from section 8.2. Suppose we want to find a 95% confidence interval for a population proportion. Determine the sample size required to produce a margin of error of at most 2.25 percentage points if we have reason to believe that the population proportion is greater than 0.64. Enter your answer as a whole number. So first, in the interest of giving help rather than answers, we're going to make some changes, and we're going to change this from 2.25 percentage points to 1.75 percentage points. All right, so then the next thing is to figure out our context. So we're in the context of finding a confidence interval for a population proportion. So we are in proportion land rather than mean land. And then what do they want us to find? They want us to determine the sample size. So the sample size is n, so we're going to be looking for a formula that says n equals. And when you're in proportion land, the formula for n equals is take a guess at p, which is what the little g stands for, is guess, times 1 minus that guess at p, and then multiply that times z star over e all squared. So that's what we want to plug into, but we need to start finding the pieces. So let's start hunting for those pieces now. First of all, for the guess at p, we're going to use this little bit of information right here that they're giving us. They think that the population proportion P is greater than 0.64. So that means that P would be somewhere between 0.64 and 1. So based on the wording, the 0.64 is not included. The 1 always is as a possibility. So P generally can go somewhere between 0 and 1, but they told us it's greater than 0.64, so that limits us to 0.64 to 1. When you go to make your guess at P, you're supposed to guess the value from your reasonable range. So here's our reasonable range from 0.64 to 1. You're supposed to guess the value from there that is closest to 0.5. So that entire interval of numbers that they've given us is greater than 0.5, so the number closest to 0.5 would be the lower end, which would be 0.64. So there's one of our numbers. And then we need the E. So the E was given to us and then changed to 1.75 percentage points. So E is 1.75%. But before you put that into the formula, you need to convert it to decimal form. So remove that percentage symbol and move the decimal 2 spots to the left. That gives us 0.0175. The only remaining piece that we need from that formula is the z star. So to get z star, we need to use our confidence interval of 95% and figure out what z star goes with that. So I'll draw a quick bell-shaped curve. We want 95% in the middle, but we have to put that in decimal form, so 0.95. That leaves 0.05 left over, but we have to divide that among the two tails. So dividing the 0.05 in half, we get 0.025 left over for both sides. And then this boundary right here would be our z star, but this negative z over here on the left is a little easier to find, so we'll do that first. That negative z comes from doing inverse normal of the area to its left, which is 0.025. So now let's go to the calculator and see what we get for that. All right, so switching over, we want to go into the distribution menu. So second distribution, we're working backwards here, trying to find a z-score, so inverse normal. And the area to the left was 0.025. So the z-score that goes with that is negative 1.9599639845, but we want to round that to exactly 3 decimal places. So that would be negative 1.959, but followed by a 9. So that 59, we have to round up to a 60. So negative 1.960. So negative 1.960, which means that the positive z star is positive 1.960. So now we have all the pieces we need on the formula. Done with our scratch work down here, we can get to work on plugging in. So our guess at P we decided was going to be 0.64. Then we do times 1 minus that, which would be 0.36. And then times z star. So our z star was 1.960 divided by the margin of error, which we converted to a decimal, so 0.175. And then remember to put that in parentheses and square it. So now we want to go to the calculator and see what we get for that. So let's switch back over there. So let's see. Our guess at P, 0.64 times 1 minus that, 0.36 times, in parentheses, the z star divided by the margin of error we want, end those parentheses, and then square. It's very important that you end the parentheses before you square to make sure we're squaring the whole fraction, not just the denominator. So we get 2890.1376. So let's go write that down. And I'm going to write it without rounding it first. So 2890.1376. And then we will round it. And if you were rounding that to the nearest whole number, you'd think 2890. But when you're determining sample size, you never want a sample size that's too small. So whenever you get a decimal, you always round up to make sure you don't get a sample size too small. So even though it's closer to 2890, we always round up with sample size. So we'll go with 2891. So just going back over some places to be careful, getting the correct guess at P by guessing the value from the interval that's closest to 0.5, which in this case was the 0.64, making sure you convert your value of E to decimal form, making sure that the three areas that you have here add up to 1 so that you know you didn't make a mistake with decimal places. Sometimes people will accidentally put 0.25 down here instead of 0.025. So easy to do careless decimal errors like that. So just a quick check on these three to make sure they add up to 1 will help you avoid that mistake. Remember to make sure that you have both of these numbers inside the parenthesis and the square on the outside so that you're squaring the whole fraction. And then make sure that even if it's closer to rounding down, that you still round up, because we always round up when calculating sample size for confidence intervals to make sure that our sample size is never too small. All right, I hope somewhere in there you found the spot that tripped you up and you're ready to head back. So good luck to you as you take the quiz again.